The universe is a pretty big place. For trillions of years, it has been a playground for stars, galaxies, and, well, us. We like to think it's eternal, a permanent stage for the drama of life. Beautiful, infinite, and forever. But physics has a different opinion. Behind the beauty lies a cold, mathematical truth that scientists have been dreading. Just like a candle, a battery, or a very long tiger nap, the universe has a finite amount of energy to spend. Everything you see is powered by a fuel that started burning at the Big Bang. And one day, the lights will go out. Not because someone flicked a switch, but because the very laws of reality won't allow them to stay on. To understand how it ends, we first have to understand why it's growing. Because the universe isn't just sitting there, it is expanding, fast. And it's getting faster every single second. Space itself is being created between galaxies. Imagine trying to hold a group of friends together, but the floor beneath you keeps growing. Eventually, you can't reach them. This expansion is the key. Depending on how much energy is left, there are three main ways the party ends. First, the big freeze. A slow, lonely fade into darkness where everything just stops moving. Second, the big rip. Imagine space itself losing its cool and tearing apart like an old t-shirt. And third, the big crunch, where gravity wins the tug of war and pulls everything back into a tiny, hot dot. Each one is more spectacular and more terrifying than the last. So let's take a look at the end of everything. Welcome to the end of time. Don't forget to bring a snack. It's going to be a very long wait. To understand how the universe ends, we first have to go back to how it all started. 13.8 billion years ago, everything was squeezed into a tiny, infinitely hot point. And then, bang! But not a bang in space, but a bang of space. The universe didn't just explode into a pre-existing room. It created the room as it went, carrying everything with it. For billions of years, the universe expanded simply because of the leftover momentum from that first big push. For a long time, we thought gravity would eventually slow it down. Like a ball thrown into the air, it had to come back. But in 1998, we found something weird. The universe isn't slowing down. It's actually going faster. We call the culprit dark energy. We don't know what it is, but it's acting like a ghost pushing against gravity. Dark energy makes up about 70% of everything in the universe. Most of reality is stuff we can't even see. It's like a gas pedal that's been stuck to the floor for billions of years, driving us toward a very strange future. Because of this, distant galaxies are moving away from us so fast that their light will one day never reach us. This is the Hubble constant. The further away something is, the faster it runs away from you. It's enough to make anyone dizzy. But this cosmic tug-of-war is what decides our ultimate fate. It all comes down to density. Is there enough stuff to pull us back, or enough push to rip us apart? So, spoiler alert, dark energy is winning the fight. And that leads us to our three final destinations. Let's start with the most likely scenario, a long, cold sleep. We call it the Big Freeze. The Big Freeze happens because the universe keeps expanding until all the gas and dust are spread too thin to make new stars. Think of it as a cosmic fuel shortage. Eventually, the star factories simply run out of hydrogen and shut down. Blue stars die fast. Yellow stars like our sun take longer. But eventually, only tiny, dim red dwarfs remain. And then, even they go out. The universe becomes a graveyard of white dwarfs, neutron stars, and black holes. For an incomprehensibly long time, black holes will be the only interesting things left, the ultimate masters of the dark. But even black holes aren't eternal. Through Hawking radiation, they slowly evaporate into nothingness. Once the last black hole vanishes, the universe is just empty. A soup of light and subatomic particles. Temperature is just the movement of particles. In the Big Freeze, everything stops moving. It hits absolute zero. No more energy can be transferred. No more work can be done. This state is called maximum entropy. This isn't going to happen tomorrow, or even in a billion years. We are talking about googles of years in the future. Scientists often call this heat death. It's a bit misleading. It's actually the coldest death possible. In the grand history of the universe, the era where stars actually shine is just a tiny blink of an eye. It's not violent, It's just the end of the story. A peaceful, eternal nap for every atom in existence. But what if dark energy doesn't just push? What if it gets aggressive? This brings us to the Big Rip. Buckle up. This one isn't peaceful at all. It's the most violent way the universe can go out. In the Big Rip scenario, dark energy doesn't just stay constant. It gets stronger, much stronger. Scientists call this phantom energy. It's like a runaway train that refuses to stop accelerating. First, the expansion becomes so violent that even gravity can't hold galaxies together. They simply drift apart. Soon, the expansion is faster than light. The night sky on any planet would go completely black. Next, the solar system is torn away from the galaxy. Then, the planets are torn away from the sun. Gravity loses its grip on everything. Planets literally explode because space is stretching too fast for them to stay whole. Finally, the rip reaches you. Your cells, your molecules, and even your atoms are pulled apart. In the last moments, the very forces that hold atoms together vanish. Everything becomes a cloud of lonely particles. And then, the fabric of space-time itself is shredded. There is no where left for anything to exist. It's a terrifying thought. But is it likely? Well, it all depends on the nature of dark energy itself. Scientists measure this with something called the W parameter. If W is less than -1, we are in trouble. Current data suggests W is exactly -1. This means the universe is probably stable. For now, even if the Big Rip were to happen, it wouldn't be for at least 22 billion years. You can finish your lunch. But what if the opposite happens? What if gravity stages a comeback? Let's talk about the Big Crunch. This is the ultimate rematch. Gravity versus dark energy. And in this version, the heavyweight champion returns. In the Big Crunch scenario, the push of dark energy eventually fades, allowing gravity to take the wheel once again. For a brief, cosmic moment, the universe stops growing. It hangs there, suspended, like a ball at the peak of its throw. And then, the collapse begins. Galaxies that spent billions of years running away now start to fall back together. But this isn't a neat process. It's a galactic demolition derby. Thousands of galaxies smashing into each other at once. Space gets smaller and smaller. Things that were safely millions of light years apart are now neighbors. Very close neighbors. As the universe shrinks, it heats up. All the radiation from all the stars gets compressed into a smaller and smaller volume. Eventually, the background radiation of the universe becomes hotter than the surface of stars. The sky itself begins to cook. Planets are roasted from the outside in. Even before they are crushed by gravity, they are vaporized by the sheer heat of space. In the final minutes, giant black holes begin to merge, swallowing everything that's left: stars, planets, and each other. The entire universe, all those galaxies and stars, is compressed back into a single, infinitely dense point. The Big Crunch. But some scientists think this isn't the end. They call it the Big Bounce. Maybe the universe just starts over again, an eternal cycle of expansion and collapse. A cosmic heart beating forever. A new Big Bang for every Big Crunch. It's a poetic idea, but is it true? Unfortunately, current evidence says, probably not. Gravity is just too weak. So we have three paths: a slow freeze, a violent rip, or a cozy crunch. Which one will it be? It feels a bit scary, doesn't it? But before you hide under your bed, there's one more thing you should know. When we talk about the end of the universe, our human brains kind of short-circuit. Because the timescales are, well, ridiculous. The entire history of humanity is like a single grain of sand on a beach that stretches for light years. Even the billions of years it took for Earth to form is just the opening credits of the movie. To reach the Big Freeze, we need to wait for a Google of years. That's a 1, followed by 100 zeros. Even our best computers give up when they try to simulate what happens that far out. It's basically eternity. For perspective, our own sun will die in about 5 billion years, long before the universe even breaks a sweat. If we survive that, we might have trillions of years to hop between stars and find new homes. Plenty of time for adventure. We could build civilizations around red dwarfs that last for ages. The end is far, far away. But eventually, even the cleverest tigers can't beat the second law of thermodynamics. the bill always comes due. The big freeze is the most likely winner. The universe becomes a cold, dark, and very quiet place. Entropy is like a wave on a beach. It eventually washes away everything we build, no matter how grand. Does that make the castle pointless? Or does the fact that it's temporary make it more special? The universe will end. But right now, it is vibrant, alive, and full of things to discover. The fact that we can even understand how it might end is a miracle of its own. We are the universe thinking about itself. So don't panic about the end. You've got plenty of time. Let's make the most of it while the stars are still burning. It's easy to feel small when you realize everything will eventually turn to dust. But small doesn't mean insignificant. Think of an ice cream cone. You know it will melt, and you know it will end. Does that make the first bite any less delicious? Life is a rare, flickering flame in a cold, dark cosmos. The fact that it exists at all is the ultimate win. We are literally made of stardust. The atoms in your left hand probably came from a different star than your right. In a universe destined for silence, the fact that we are here right now, making noise and asking questions, is amazing. We are the way the universe witnesses its own majesty. We give the stars a reason to shine. Because if the end is inevitable, then the only thing that truly matters is what we do for each other, right now. Kindness, curiosity, and a bit of humor. These are our best weapons against the darkness of the void. The story of the universe is billions of pages long. We are only on a few of them, but they are the best ones. So don't worry about the big freeze or the big rip today. We have a lot of living to do first. The end is just a theory. The present is a fact. And the present is pretty great. We'll keep watching the stars for you, just in case gravity decides to change its mind. Because after all, even if the universe ends, at least we had a front row seat to the show. Stay curious, stay kind, and remember, you are the stardust that learned to think. See you in the next one. This video was made possible by viewers like you, and by our friends at Cosmic Tiger Tea, the tea for existential crises. If you want to support more videos about the end of time, check out the link in the description or scan the code on screen. Now, back to our regularly scheduled programming. Or rather, the end of it. Thank you for your support. A special thanks to our patrons, the researchers, and everyone who kept us from having an existential crisis. Our scientific team worked day and night to ensure these 3 ways to die were 100% accurate. For now, and to you, our wonderful community, you're the reason we keep looking up. Don't forget to like and subscribe. This channel is run by a small group of curious tigers who believe that learning is the best adventure of all. The universe might be finite, but our curiosity is infinite. Keep looking up. We'll see you in the next world. And now, off to the next mystery. Where should we go next? Black holes? The multiverse? You decide. This has been a Science Tiger production. Thanks for being part of our pride. Wait, is that a smudge? There, much better. Oh, are you still here? If you missed our last video about why black holes are basically cosmic vacuum cleaners, click right here, or let the YouTube algorithm decide your fate. It's almost as unpredictable as dark energy. Seriously though, thanks for staying. Go have some ice cream. You've earned it.